Okay, so welcome back to more Predator Prey Bears and Fish, and we're doing part 2 today. Okay, so last time we created a basic framework and we created an array to map the landscape, and we placed fish in that array at random, and we had the fish moving around, and we had a little timer set up to refresh the screen every half a second, and it was pretty jerky, but it was okay. We could see the fish moving around. What we might do today is think about things a little bit more. We might start looking at collisions. So we'll add bears into the mix as well. So we'll add bears in, and then we'll think about collisions. So when a bear and a fish collide, the fish disappears. The bear eats the fish. Okay. When two fish collide, they create a baby fish, and which is placed at a random location in the array. So I mean, normally you'd expect if two fish collide and they produce a baby, it would be somewhere near them, but we're just going to place it into a random location in the array. So it could be on the other side of the river even. Okay, so we're just going to put them in somewhere randomly. Same when two bears collide, we'll make it so they produce a baby bear somewhere in the map. Okay, the parents don't have to look after it. It's just fully grown and suddenly appears in the map. Okay, so let's have a go at that. So here's our code. So let's go down, and so we'll first of all we'll go to our constructor, which is our constructor for our Predator Prey Bears and Fish class, and this is where we place the fish. We also want to do something similar for bears. So let's have starting bears, and starting bears. So we'll create another constant, bears, and we'll make it. We've got I don't know, 20 starting bears, doesn't matter, just so it's something different. So starting bears, and we want to really just duplicate this code here, but change it to starting bears, have a bear count, and equals new bear. Okay, so everything's pretty similar. So we're actually writing the same code, and we've got it twice. Okay, don't panic, we're going to tidy things up at the end. Okay, we're going to go through and remove all the duplication and streamline things down right at the end. Okay, which might be part 3. Okay, we just want to get things working for now. We'll worry about making things beautiful and sleek and elegant later. Okay, so let's just copy that code. Okay, there it is there, and we'll have, I also need the bear count, int bear count. Bear. While bear count is less than, add 1 to bear count, equals new bear. And starting bears. I think it was starting bears. Yeah, starting bears. So bear count, starting bears, equals new bear. And that should be it. Let's just check our toString. And down here we've got a dot coming out for null, an F coming out for fish. Just need to check what a bear is and add support for bear. Else if it's an instance of a bear, then we output a B for bear. Okay, now we haven't added collisions yet, but we've now added bears into the landscape. So when our grid first displays, there should be 15 fish in there and 15 bears. Okay, let's do that. And there it is there. So you can see the bears and the fish moving around. There's a bear moving up and down and around the place. Bears moving around, fish moving around. Okay, so that's working great already. Okay, so the next step is to add, we'll add in collisions so that two fish can collide and produce a baby fish, and so on. Okay, that's working great. So down here with our move, we've got if what's moving is not a null, so in other words, it's a fish or a bear or something else we might add later, we'll get the chance to move, and if the chance to move is in a certain range, we'll proceed and see if the animal, whatever it is, wants to move. And down here we've got if the x change is not equal to 0, so in other words they're moving horizontally at least 1 square left or right, and the new coordinate for the x is in the bounds of the array, and the new destination where we want to move to is equal to null, then we're allowing the fish or the bear to move. Okay. So what we're going to do now is just change this. We're going to comment this code out, so you can see the old and the new. Okay, so I'm just commenting out the old code here. And I'm now going to copy this code down below and change it so we can add in the collisions for bears and fishes. Okay, so so what I might do is pull that inside to another if statement. I'm just thinking of the best way to do it. So we'll just close that if statement there, get rid of that round bracket. Oops. Delete. Okay, so I just made that if statement a lot simpler. And what we want to do is add an if statement inside here. If it's basically that. If x new y is equal to null, then we'll do the move. Okay, and then otherwise, what if they're the same sort of creature? Otherwise else, so we want to get the instance of where we're moving from and the instance of the class name for where we're moving to, and compare those. And if they're the same class name, then we're going to create a new baby. Okay, so two bears are trying to move into the same cell, or two fish are trying to move into the same cell. Okay, so we need to get the class names or the class types of the data and then compare them. If it's two bears or two fishes, we've got a baby coming. So we'll just get the code for that. Okay, so we're going to get the class of the of the data where we're moving from, or where we're moving to, and we'll compare it to where we're moving from. And if they are equal, so x and y is where we're moving from, x new y is where we're moving to, and if they're the same, then we're going to create a new little fish. Now there is a problem with that, and that is where we could be moving in the x and y, and also in the y. We could move in the x direction, the horizontal, and we could also be moving vertically. And this is going to produce a new fish before we've even thought about, or a new bear before we've even thought about what's happening with the vertical. Okay, so we probably don't want to do that for each of these cases here, x and y. We're going to do it down below. Okay, so this is the sort of code we want, and so it's if the class names are the same, or the data classes, the parent classes of the cell we're moving from and the cell we're moving to are the same, then we want to create a baby. So a bear's trying to move onto a bear, or a fish is trying to move onto a fish. So create a baby, fish or bear or whatever, if we add more animal types in the future. Else if they're not the same, okay, so where we're moving from is not the same as where we're moving to, that's when we're going to apply our rules of if bear is moving onto a fish, we want to eat the fish. Okay, so that's the sort of logic we want to do, and we want to do it after the x and the y coordinates, the new x and y coordinates have been sorted out. Okay, so what we might do here is we'll create some booleans to help us here, because we don't want to do it here while we still haven't worked out what the vertical coordinate is, and we don't want to do it down here again after we've already worked out what the x coordinate is, because we could be eating multiple fish with one move or creating multiple babies with one move. Okay, so we want to get the final position organized and then do the move. So what we might do is create a couple of booleans. So this code's going to get a bit messy for a while, and then we'll simplify things. Don't worry. Okay, so let's create a couple of booleans. Boolean x has moved, or x can move. Set that to false, and we'll do one for y as well. Y can move. In other words, can you move horizontally? And y can you move vertically? That's what they mean. Okay, and if these conditions here are all true, then we can say we can move horizontally, so that's true. And if all of these conditions are true, we're going to make this the same as the above. Then we'll say y can move is equal to true. Okay, and we'll delete that for now. Okay, and we'll cut all this out for now. Cut all this. Control X. Okay, so we're just having, can we move or not? Okay, so if the change in the X is not 0 and we're in the array, then we can move horizontally. If the Y change is not equal to 0, we're moving vertically, and we're in the array, then we can move vertically. Okay, so we're just working that out for now. Still got other code in the buffer there. We're going to use that now. Let's just paste that down below here. Okay, so if X can move is equal to true, or Y can move is equal to true. So if either of those are true, then we've got a move going on. Okay, we're going to move either vertically or horizontally or both. Okay, so this is where we need to check what we're moving on to, and whether we're moving from a bear onto a fish or a bear onto a bear and all those sorts of things. So we're getting onto the stage where we can do the collisions now without repeating code. So all this worked out above here is where we're moving to a valid place. Are we moving, and is it a valid place? So if we are moving to a valid place for at least one of those directions, we're going to move. And let's work out some final coordinates. Int x final. So in other words, the final location where we're going to move to for this bear or this fish or whatever is equal to x. We'll set it equal to the original coordinate of where they are now before they move. Same for y final. Y final is equal to y. And if x can move is true, then x final is equal to x new. Okay, so if they can move horizontally, our real final destination is our new x new coordinate. Same for y. Copy and paste that 2 lines of code. If y can move is true, then y final equals y new. Okay, so now we've got these worked out, we can now do the move and take a look at collisions and things. Okay, so we're not talking about x new anymore and y. We're talking about x final and x final and y final and y final. Okay, so we're talking about the final destinations of where we're moving to, x and y. If where we're moving to is null, there's no animal there, we can just move. So our new location, we're moving that, wherever the fish was, we're putting them in their new location, and we're sitting where they were to null. So we're just moving the fish across, and then setting where they were to null. Otherwise, if they're new locations, x final, y final, I'll just change all these as I go. X final, y final, y final. I'm just changing all of these x's and y's to x final, y final. That's the final location we're moving to. Okay. Actually, sorry. That should have been x. And that should have been y. X. Y. Okay. So if the animal type from where we're moving from is the same as the animal type we're moving through to, we know it's not null, because this would have been picked up if it was null. So if we're moving from a bear to a bear, if what's in the original cell was a bear and where we're moving to is a bear, then we need to create a new baby bear. Or a fish. So if fishes are moving onto fish, that's fine. So that's the code we need to put there to create a new bear or a fish. And we did that up in the constructor, so we're just going to take that code and adapt it slightly. And down here, if the if where we're moving from is not the same class as where we're moving to, then we've got a bear moving onto a fish, or a fish moving onto a bear. And in that case, the bear's going to eat the fish. Okay. Sorry about the break there. My Camtasia keeps crashing. I don't know what's going on. It seems to be very buggy software, Camtasia. But anyway. So down here we need to create it. Need to delete the fish. Whichever one's the fish, we need to delete it. Okay. So if we can do that straight away. So we're going to say if that equals fish. Okay, the equivalent of this sort of code. I'm just writing pseudocode for now. So if it's a fish, we want to delete it. Otherwise, if where we're moving to is a fish. So this is just pseudocode. I'm going to fix this up in a second. Y final, X final. So this is pseudocode. So I'm just planning out, showing you what we're going to do. So if the class where we're moving from is a fish, then the bear's moving on top of it, so we're deleting it. And if where we're moving to is a fish, then the bear's moving onto a fish, and we're going to delete it as well. So it's either a fish moving onto a bear or a bear moving onto a fish. So I'll write that code in a second. Okay, so let's write the code for this now. And so it's going to be very similar code to this, but and again, there's many ways to do it in Java, many ways to do it. I'll just show you one way. So if we get the name of the class, get name, uppercase N, and if that equals the string fish, so if that equals true, then where we're moving, where the original class or the original location was a fish, so the bear's going to eat the fish. We know they're not the same. Something's moving on to something that's different, and we've only got bears and fish. So if where we're moving from is a fish, then a fish is moving onto a bear, and we want to delete that fish. Okay, and why we do that is we just go, the original location is equal to null. Okay, set the original location to null. Otherwise, if where we're moving to is a fish, that's where the X final, Y final come in. Y final, then we set that location to a null. Okay, or do we? So here, a fish is trying to move onto a bear, so the bear stays where it is, and the fish gets erased. But when a bear moves onto a fish, the destination is a fish, so the X final, Y final is a fish. Then we want the bear to continue to move there, don't we? So we'll just go equals the original. Okay, so the bear moves across. The fish that was in that cell's now gone. It's been eaten. Okay, no longer exists. Before we hop in and creating baby stuff, we might just improve things slightly. So we might have a bear count and a fish count and display that to the screen for each frame of iteration. So we might make these items here, fish count and bear count, we might make those class data. So we'll move those up to class level, so they're instance fields up here. So we've got fish count is now up there, and we'll move bear count up as well. Make those private. It's always a good idea to make your data private. Private, private, private. With your constants, because these are constants, you can safely make those public if you want, or make them private. Doesn't really matter. They're constants. Nothing outside the class can change them. Make them public. Secure random, that's just something we're using inside our class. We'll make that private as well, just a good measure. Don't want anything messing with it outside the class. Okay, that's all looking good. So we've got fish count and bear count are now instance fields of the class. So every time we create an object of this type, it gets its own fish count and bear count. We're adding one to it here. And what we want to do down here is, so we want to display fish count and bear count in the toString method. So after we've generated the array with all the dots and the F's and the B's in it, we want to then display the outstring plus equals, so outstring equals outstring plus fishes, or fish, plus fish count plus bears plus bear count. And I just noticed something else wrong up here when I scroll past as well. That should say bear in a comment. Add a bear to a random location. Okay, so we're down in the two-string method, and we just added fish count and bear count there. And if you missed that last little change I did, I just changed the comment up here in our constructor. Add a fish to a random location, add a bear. When I copied the code up above, down it still said add a fish when it was adding bears, so just fix that. Okay, so that should be pretty close. We should now be able to at least see when fish are eaten. Now what one? My Camtasia's just crashed again. Oh dear. Okay, and back again. And the other thing we want to do when we erase a fish or eat a fish is we want to subtract one from the fish count. So fish count. Just do a fish count minus minus. Okay, so that's down here in our collision detecting code that we were working on before. So and also there above as well. So if where we're moving from was if a fish is moving onto a bear, we want to subtract one from the fish count, and if a bear is moving onto a fish, then we want to subtract from the fish count as well. Okay, so fish are being removed from the array slowly. We'll come and tackle this creating a baby next. Okay, so we might just do a quick run here and see how we're going. So 15 bears, 14 fish. So a fish has been eaten. There's not many bears. I mean, there's a lot of empty space on the map, so the chances of a bear eating a fish are pretty slim at the moment. We could now we're down to 13 fish, 12, 11. Okay, so the fish are getting eaten, so our code looks like it's working fine. 10. If we put more bears on the map and more fish, we'd have a lot more eaten. Eventually we'll get down to 0 anyway. And then the bears are in trouble. Okay, so that looks like it's working. We'll verify that later on when we do some more testing. Let's now look at this code. So create a baby fish or a bear. Let's get back up to our constructor. And we had this nasty duplicate code here that I was never happy with, but I just left it there for now. So this code here, adding a fish, is basically the same as this code down here for adding a bear. It's just we've changed bear to fish, or fish to bear down here. It's bear count and bear. Okay, so what we want to do probably is to save us copying this code and duplicating something like that down below when we're creating a baby, we probably want to make this generic. So let's see if we can do that. So let's just copy this now, Control C, and we'll paste it down here. And I'll call it private. I'll make it a private method because it shouldn't be called outside of the class. Private void. It could be a void method. Add new animal. And I'll pass in the animal. Okay, so something can be passed in. It could be an animal or a bear or a fish. And so we'll get and it's just going to add one. Okay, so int add count is equal to 0. In fact, I might even make it return an int. I'll make it return an int, and I'll show you why later, because you want to keep track of that number of bears and number of fish thing. Okay, so add a new animal, and we've got an add count there, and while add count is less than or equal to, while add count is equal to 0, so we're just going to add one new animal. So while add count is equal to 0, we'll change that there to add count plus plus. So while add count equals to 0, we'll create a new animal object equals the animal passed in, whatever the animal is, and yep. So what the idea is, we're going to call this like this. So int fish count is equal to add a new animal, new fish. Okay, and we'll call this in a loop. Fish count, just go fish count. Fish count equals add new animal plus equals. Okay, and so this is going to return the add count, which will be a 1. Okay, so while add count is equal to 0, it's going to keep looping until we eventually find a place where the animal can go and add 1 to the count, and then we'll return that add count back. So back in the calling method, we can go fish count plus equals. In other words, fish count equals fish count plus, and add new animal, and we'll say new fish, round brackets, or new bear, or if we add other animals later on, we can add those in as well. Okay, so this is a generic method now, and it will work for any type of animal. Okay, so other ways we could do it as well. We might come back and revisit this later, but this is basically what we want. So when we're adding fish, we just want to call that up here. And we can delete all that. Okay, so you can see we've streamlined down our code quite a lot. And similar sort of code for our bear, equals new bear. And it's... Okay, so our code in our constructors become fish count plus equals add new animal, a new fish. And we're adding bears, bear count plus equals add new animal, new bear. Okay, so that's streamlined our code a lot. And that's quite nice. So when we want to add a baby bear or a baby fish, we can just call this once. So we'll grab those 2 lines of code. I just really want that line of code there and that line of code. And I'm going to transfer those down below. So to where the collision happens, that's here. Delete. So I want to call one of those depending on whether we've got fish moving or bear moving. Okay, so, and again, there's many ways we could do it. We could probably just grab this code here. That's probably going to be the easiest. Okay, so if where we're moving from or where we're moving to, it's the same data. If it's a fish, then we want to create a new fish somewhere randomly in the array. We're not going to create it next to our fish. So it's going to be a baby somewhere in the array, somewhere in the landscape, and the same sort of thing for bear. So if it's a bear, we're going to create a new bear. And that should be it. So now, when 2 fish collide, we'll create a new fish, and when 2 bears collide, we'll create a new bear, and that should be pretty cool. So let's just increase the number of fish. We'll go up to our constants up here, and we'll make it 45 fish, and we'll make it 40 bears, and see what happens. And you can see things are 44 bears, 45 bears, 42 fish, 46, 47, 48 fish. So you can see the bears are increasing quickly, and of course they're going to, because bears can't be destroyed. Okay, we haven't added anything in there that's going to hurt a bear. So, so we've got 875 bears there and only 2 fish. I think something's gone wrong. It's no longer looping. So I think we ran out of bears, and our program probably crashed or something because it's no longer looping. But that's quite funny. So you can see the population of bears quickly explodes because there's no mortality built into the program yet. It's just a very simple simulation at this stage. Okay, so what we can probably do to improve things slightly is only remove a fish if only remove a fish or go ahead with this deletion if the number of fish is greater than 0. So we don't want to start getting into negative fish. If fish count is greater than 0, then we can remove the fish. Okay, and same down here. Oops. Same down here. So we'll just grab that bit of code there, the top of the if statement, and paste it down there as well. Okay, so here we're deleting a fish because we've got a fish moving onto a bear, so we're erasing the fish. And here we're erasing a fish or deleting a fish because a bear's moving onto a fish. The final destination is a fish. So we can only do either of those things. We can only remove fish if there's more fish to remove. Okay, so that should improve things. Let's do a run. 45. So bears will start increasing really quickly now. 64, 44, 41 to 81, 37 to 120. And now it's just exploding. Bears are exploding. And pretty soon, yeah, down to zero. So we've eaten all the fish again. So at the end of the day, it's a pretty sort of silly animation because we don't have any mortalities built in. So let's have a look at the question again, and we'll just make sure we've got everything done. So simulated ecosystem, 2 types of creatures, bears and fish. The ecosystem consists of a river, which is modelled as a relatively large array. Each cell of the array should contain an animal object, which can be a bear, a fish, or nothing. And we've done that. In each step, based on a random process, each animal either attempts to move into an adjacent cell or stay where it is, and we've done that. If 2 animals of the same type are about to collide in the same cell, then they stay where they are, but they create a new instance of the type of animal which is placed in a random empty cell in the array. And we've done that. We've created babies. That's fine. If a bear and a fish collide, then the fish dies. It disappears, which we've done. Use actual object creation, and we've done that. Via the new operator, we've done. To model the creation of new objects, we've done that. And provide a visualization. We've just done a simple visualization. Camtasia's crashed again. Okay, back again. Another Camtasia crash. A $3,500 laptop, and Camtasia is still horribly unstable. I've run it on Core i7 desktops, Core i3 desktops, Core i7 laptops, Core i3 laptops, Windows 7, Windows 8, Windows 10, and on every machine, the latest version of Camtasia is just really, really flaky. It's always been flaky, but now, my goodness. But anyway. So with the predator-prey thing, you might have noticed the animation was locking up at the end there. It wasn't progressing further. And that's because we'd run out of slots. So down here in our ad, we probably want to say... we probably want to do an if statement to make sure there's enough empty slots left. So before we do an ad, we want to make sure fish count's not too large and bear count's not too large. So what we could do is work out the number of empty cells in here, and we might do that. Okay, int total cells so far is equal to fish count plus bear count. This will do for now. We can fix this up later. And if the total cells so far is less than the width times the height. In other words, our array landscape, number of cells in our array landscape, total cells so far, then we're okay to go ahead and add. Just fix that comment there. Add an animal to a random location in our ecosystem array. Okay, so we'll just fix that up there, indent that, bring that back, delete that blank line. Okay, so we're only going to go into this loop here if the total cells so far, if there's room to add the animal, basically. Okay, so the total cells taken so far is less than the number in the array. That should take care of that. So now our program should keep running even when the number of bears has exploded. 43, 46, 50. Once it gets to about 100, it really shoots up. There it goes. 780, 90, 99, 105. So we should see the array just fill up with bears and, oh, 852 and 1. So, not sure why it's locking up here. We're not, maybe it's having trouble fitting the bear in, the bear in somewhere. It's hunting for that random location over and over and over again. And it's finding it really slow. Ah, it looped then. Oh, no, maybe it didn't. Okay, anyway. We've more than answered that part of the question, so I'm happy to call that completed. So the next question in the same series is write a simulator as in the previous project, but add a Boolean gender field and a floating point strength field to each animal object. Now if two animals of the same type and try to collide, then they only create a new instance of that type of animal if they are of different genders. So it's going to be a bear male and a bear female, or a female fish and a male fish. Otherwise, if two animals of the same type and gender try to collide, then only the larger strength or the stronger animal survives. That's interesting. So that's adding a bit of mortality in there. So if you're watching this video and you're keen to pursue further, which you should also always try to do, I want to add like I do with all of my in-class questions, 2.33, and so this is the original question. So add a GUI interface to your simulation. So instead of having output going to the console screen, you could have an array or a grid of labels or buttons, and a B or an F or a dot going into each one of those labels or buttons in a grid. And that would be pretty nice. You could have a nice graphical display instead then. You could make it so you could add bear mortality or lifespans. And you could add mortality rates, birth rates, lifespans, and so that sort of thing. So your birth rate would control how often a bear could breed. So maybe a bear could only have 2 cubs a year, and a fish could have, if they lay eggs, a fish could produce, 1,000 offspring a year or something like that. So, and mortality rates, how long does a fish live, and how long does a bear live? So bears live a long time. Fish generally don't live as long. And lifespans and things. So mortality rates is what's their chance of dying, so if they're living in really hard areas, you could like not much food around, then the mortality rate's higher, that sort of thing. And the other thing you could do if you're keen to explore, and that's fantastic if you are, Camtasia. Okay, back again from another Camtasia crash. So the other thing you could add, if you wanted to, is you could add, there's a whole lot of stuff you could add. You could, add the ability to speed up time or slow down time. Maybe a slider across the bottom or vertically, so you can speed up how quickly the program loops and displays. Mortality rates. You could add other types of animals. So you could add, something else the bear can live on, something else that maybe hurts the bear, something else that eats fish, something a fish can live on. You could add extra animals in if you wanted to. The sky's the limit. And of course, the good one to add would be to add zones to your landscape. So bear-only zones. So there's shallow water, and there's land, and only the bear can go onto land. And there's shallow water, and there's deep water, and only the fish can go into the deep water or under rocks into rocky caves and so on. Bear-only zones, fish-only zones, like deep water and land. Okay, so there's a whole lot of stuff you could add. Use your imagination. So keep exploring, have fun. The trick is with programming is to just try and explore and solve a whole range of problems, and you'll become good at it, and comfortable, which is most important. Okay, hope that was useful. Thanks for watching.